Hello, welcome to this video. I'm going to cover how to calculate relative atomic mass. The kind of question you could be faced with would be something like this, where you're told that naturally existing copper has two stable isotopes, copper 63 with an abundance of 69.2%. Now, abundance just means amount, and copper 65 with an abundance of 30.8%. They want you to calculate the relative atomic mass, also known as the AR, of copper to one decimal place. Now, if you take a look at the periodic table, you'll notice when you look at copper, there's a decimal. Now, the top number, that is your relative atomic mass, which is the number of protons and neutrons, which are whole subatomic particles. But copper has a decimal value, and you can't have half of a proton or half of a neutron. And this is because in nature, copper is found with different isotopes. And an isotope is an atom with a different number of neutrons, but the same number of protons. So let's get back to our copper question. Now, the first thing you will need is the formula. That is the relative atomic mass equal the sum of the isotope abundance multiplied by the isotope mass. And you divide that by the sum of the abundances of all of the isotopes. And the best way to learn this is let's just do a practice question. I'll go through 3 questions in total. These questions are classic in GCSE, and you'll always have one in a paper. So first of all, we're going to look at the isotope abundance, and that's our amount in a percentage. Here we're being told that copper 63 has 69.2%. So if you put that in bracket, and you're going to start off with the isotope abundance, so that's 69.2, then you're going to multiply that by the isotope mass. And the isotope mass of copper 63 is 63. Close your bracket. Now we're adding, and the second one will be the abundance of copper 65, and that is 30.8. We're going to multiply that by the mass, which was 65, and close your bracket. Now we're going to divide all of that by the sum of the abundances. This will equal 100. So our first one was 69.2 plus 30.8. They wanted the answer just to one decimal place. That would equal, put the full amount in first and then correct that to one decimal place. I've often seen questions where a mark is given for that value, so don't leave it out. But our correct answer is 63.6. Now let's try another one. This one, probably the most classic of all relative atomic mass questions, and that is chlorine. We're being told here that chlorine 35 has an abundance of 75.8% and chlorine 37 an abundance of 24.2%. If we look at the periodic table, notice chlorine is 35.5%. Let's see if we can get something similar. Again, you need your formula. Let's write that out so you get used to learning it. Relative atomic mass, which the symbol is capital A and then a subscript R. That equals the sum, which is the addition, the isotope abundance multiplied by the isotope mass number, all divided by the sum of abundances of all the isotopes. Let's put our values in. So we have chlorine 35, so open a bracket, and chlorine 35 has 75.8% multiplied by 35. That's the mass number of that isotope. Plus, remember we're adding, this is the sum. The abundance of chlorine 37 is 24.2% multiplied by the mass of chlorine 37, which is 37. And that is divided by the sum of the abundances of all the isotopes. And remember, that's going to equal 100. So you've got 75.8 plus 24.2. Put that in a bracket. Again, you're going to put that into your calculator, write the full answer, but then present your final answer to the amount that the question asked, and you were asked for one decimal place. And here you can see as the periodic table showed, 35.5. I've got one last one for you, and this one's lithium. But before I do go into this, I just want to introduce myself. I'm Sally. I'm the founder of Learn Page by Page. As you can hear from my accent, I am from the UK, but I do also teach US students. So in all my videos, I will try and cover both curriculums. I'm a fully qualified teacher, and I also coach homeschool parents. So if you found this video helpful, go ahead, hit subscribe. That would really help the channel. And if there's anything else you would like me to pull up, pop a note in the comments below. I'd also add a video link at the end to balancing chemical equations. Anyway, back to the question. Remember our formula, and that's the relative atomic mass, and then sum of the isotope abundance multiplied by the isotope mass, and we got sum of abundances of all isotopes. You can see here we're dealing with lithium. So lithium 6 is 7.6% and lithium 7 92.4%. And before we go into this, it might be worth looking at the theory, because we're dealing with lithium and that is a little bit of a smaller atom. So let's have a look at the structure of a lithium atom. If we look at the periodic table, there's lithium there. So on the periodic table, an atom of lithium is said to contain 7 protons and neutrons. The bottom number is your proton number. So if you say 7, take away 3, that tells you that lithium has 4 neutrons. So the 2 lithium isotopes we're dealing with here is lithium 6 and lithium 7. We go ahead and draw those, and here we are. I've drawn just the lithium isotope nuclei. Nuclei is the plural word form for nucleus. This one here, that is lithium 6. That's this one that told us in the question there was 7.6%. And this one here is lithium 7, which we know there's 92.4%. If you notice, they both have this bottom number here. That's the number of protons. If you remember when we looked at the periodic table, you see lithium had 3 protons. Then the top number is the number of protons and neutrons. If we look in the first one, we can see the orange spheres, they're the protons. So there's 3 protons in both, but in the first one, there's 3 blue spheres, they're the neutrons. And then here, with lithium 7, there's 4 blue spheres, and that's because there's 4 neutrons in lithium 7. And then the orange spheres, you can see I've gone ahead and labelled them as the protons. Now let's go back to the question and let's calculate the relative atomic mass of lithium to 1 decimal place. So we start off with the AR and the sum of the isotope abundance. So our first one, we'll do lithium 6. And that's 7.6% multiplied by 6 plus lithium 7 at 92.4% multiplied by 7 all over. This is your amounts. 7.6 plus 92.4. Pop that in your calculator. Again, remember, although they want it to 1 decimal place, put the full amount down. 6.924. And to 1 decimal place would be 6.9. There we are. That should be about everything. I hope that helps. Here's the video that I promised you on balancing chemical equations. It's got some really good techniques that I was taught during my advanced chemistry teacher training by an organic chemist. And thank you so much for watching, and see you next time.